Okay, this first question. The formula is pi r squared L, and as Ben says, it doesn't matter what the shape is, so long as it's got a uniform cross-sectional area all the way through. The volume is just the area of the cross-section multiplied by the length. So in the case of a cylinder, it's pi r squared multiplied by the length. Okay, and that's worth remembering. Now I just put in the figures. So pi, press the pi button on the calculator, times the radius, which is 18.2, squared times the length, which is 138.6. So that's what I key into the calculator. And then I get an answer. Anybody? Anything else? Okay. So that's the answer. Appropriate accuracy. Look at the figures you put in to answer that question. Remember, we talked about this so many times. How many significant figures there? How many there? So what's a reasonable accuracy in the answer? 4, yeah. So round that, please, to 4 significant figures. Yeah, 1442 I hear. What do I do next? 0, 0. Good. I've got to hold them in the right column. So 144200. What comes after that? Millimeters cubed. Good. So Ben, big number, but I'd expect that because a cubic millimeter is quite a small unit. And then at the end goes my accuracy. 4 significant figures. Don't forget that, otherwise you're implying that's an exact answer, which it isn't. You've rounded it. That's the sort of thing I expect to see. When you're into engineering, you're in that sort of thing, and when you do more of these sorts of calculations already, possibly, you do a calculation out in the field with real objects, you want an accuracy. I was doing some work with the foundation degree students yesterday, and we were calculating forces on beams. And it struck me how important that was at that point, because that gives you a tolerance. 4 significant figures in that answer. Say it was a force. You need to know the tolerance because you need to know the biggest it can be to allow for that. And so the importance is accurate. Is important. The accuracy is important. So please try and get used to doing that. Not everyone does, but as good engineers, you should. Okay. Number 2. What's the right ratio? Which one are we involved with? Angle. What side is that called? What's that side called? No, that's the adjacent. So which ratio is it? Yeah. Hang on. Sine of x equals opposite over hypotenuse. That's the ratio we're interested in. You should know that. SOHCAHTOA. Sine is opposite over hypotenuse, and so on. So, next thing is I'm after the angle, so x equals the inverse sine, sine to the minus 1, of the opposite, which is 3.58, over 7.03. So on my calculator, I would press the inverse sine, so shift and then sine, and then I get this open bracket. And then I use the fraction button. So I can then enter 3.58 over 7.03. And then it gives it to me in one hit. So if you do that, please, on your calculator, what's the answer? 30.61. 30.61 degrees to 4 significant figures. Everybody get that? It's possible that some of you won't get that. Why? Excellent, Sam. Yeah, you've got to check that you're in degrees, not radians, and that's such an easy mistake. Okay, So be careful. If you want degrees, make sure you're in degrees on the calculator. Okay. It's very reasonable to round to the nearest degree, by the way, on those. We don't often measure parts of a degree, so 31 degrees would be fine as well. Number 3, what fraction of the data lies within? No? Yeah, but one standard deviation either side. You remember we wrote down what fraction that was. Roughly 2/3 of the data lies within one standard deviation either side of the mean. So about 2/3 is the answer, or 67%. Okay? So if I plot a graph of a normal distribution, it would look like this. That would be the mean in the middle, and one standard deviation either side of the mean would include about 66, 67% of the data. So 1/3 of the data would be out here somewhere. Next, so in the light of that, if you do a study, the mean is 34 and the standard deviation is 5.6. So if we go back to this other question here and look at this diagram, the mean is 34 and the standard deviation is 5.6. So that means this point here is 34 plus 5.6, which is 39.6. This is 34 take away 5.6, which is 28.4. So now the firm claims that the length of the rivets is 36, which is about here somewhere. So is that a reasonable claim? Why not, Ben? So roughly how many of the rivets are going to be a long way out? So it depends on the tolerance. So there's no one answer, doesn't it? If you want it to be exactly 36 centimeters, there's going to be a lot of the rivets that are outside that range. Yes, so it depends on the tolerance you want. Yeah, you could have quite a lot smaller, couldn't you? So you argue something along those lines. You could easily argue, yes, that is a reasonable claim if you're not interested too much in the length. If plus or minus 1 or 2 millimeters would do for your process, then that's fair enough, isn't it? Okay. Exactly, right, Richard. It depends on the tolerances you want. Ben? Yeah, yeah. Okay. But some sort of sensible answer around those things. If you're doing some sort of study, it depends, as you say, in what you're after. So I'm asking you this question because in the assignment you're asked to comment on the results, so you can talk sensibly, hopefully, about them. Okay? Right.